I will be solving statistics, chapter 4, section 2, course practice quiz. Let's begin, inshallah. A piece of equipment has two control boards, S and T. The probability that S malfunctions, so probability of X malfunctioning, is 0.24. The probability that board T malfunctions is 0.12. And the probability that both boards malfunction at the same time, so the intersection of S and T, both of them, is 0.1. Let A be the event that board S malfunctions, so we can change this one to A. And let B be the event that board T malfunctions. So we can do A intersection T. So what does it ask? What does the question ask? Which of the following relations must be true in order to show that the events A and B are not independent, meaning that they're dependent? Okay, so the two events A and B are independent of if their product is equal to the intersection of A and B. So to check if they're dependent, these two must not be equal. So the probability of A times the probability of B must not be equal to the intersection of A and B, which is 0.1. So this is the answer. Part B. What is the probability that at least one of the two boards malfunctions during operation? At least one, it's like saying or. And is usually, if they use and, we usually use intersection. If it says or, we use union. So here it says at least one, it's like this or that. At least one, it's either one or two, you know? So we find the union. So P, A union B, there's a formula that we must memorize, which is the probability of A plus the probability of B minus the intersection of A and B. So we do 0.24 plus 0.12 minus 0.1. So we put it on the calculator. We do 0.24 plus 0.12 minus 0.1. We get 0.26. So this is 0.26. Question 2. 3 spinners, each divided into 4 equal sectors and each labeled with numbers 1, 2, 3, 4 are spun, and the sum of the 3 numbers they stopped at is observed. Look, we usually are used to 2 spinners and we find the sum. So we usually do 1, 2, 3, 4, 1, 2, 3, 4, and we find the table in between, which are the sums of the two numbers, the two corresponding numbers. But in this case, they gave us 3 spinners. So I made up a rule from my head. I didn't get it from ChatGPT. I just used common sense. If we have 3 spinners, we cannot use a 2D table. So we have 3 spinners. Each one has 4, like 1, 2, 3, 4. 4 sectors, each one labeled 1, 2, 3, and 4. So if we were to consider 2 spinners, it would be 1, 2, 3, 4, 1, 2, 3, 4. But we have an extra third spinner, so we can multiply these values by 2. Okay? So it will be 2, 4, 6, and 8. In this case, we take into consideration all 3 spinners. So it says, given that the probability that the sum of the 3 numbers obtained is equal to 12 is 1 over k. So 8 plus 1 is 9. So 8, 9, 10, 8, 9, 10, 11, 12. There's only one way in which where if the three numbers from each spinners are added, where it's equal to 12. It's only one. There's only one possible case. So we do 1 over the total number of probabilities, like the total number of arrangements, like the total summations. We usually, like when we find the total, we do 4 times 4, where we will get 16. This is for only 2 spinners. If we want 3 spinners, we simply add an extra 4. So we do 4 times 4 times 4, where we will get 64. 64. It's a bit hard to explain, so I hope you understand it, inshallah. If you have any questions, you can just ask. So, the probability all 3 spinners stop on the same number can be expressed as 1 over m. So, this should be equal to this divided by 2, so that the 3 spinners have the same number. So we have 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. So we only have 4 possible ways in which the 3 spinners land on the same number. So we do 4 divided by the total number of arrangements, which is 64. So we do 4 divided by 64. This we didn't have an AMS about it before, so it's a bit confusing. So it's 1, but inshallah, if you understand it, it would be easy. Okay, so 1 over 16, so the first one is 64, the second one is 16, because they only want the denominator. So the first one is 64, and the second one is 16. Question 3. What does it say? It's a long question. So 2 fair spinners are spun at the same time. The first spinner has 4 sides. 1, 2, 3, 4. And the second spinner has 6 sides. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The score of each spinner is the number it lands on. Let A be the event that the score of the first spinner, alone without the second one, is a composite number. A composite number is a number that's not a prime number. So it means that that number can be multiplied by any 2 numbers which are different from 1 and the number itself. So, in the first spinner we have 1, 2, 3, and 4. The only composite number in all of them is 4, which can be 1 and 4 and 2 and 2. Like we can do 2 times 2 to get 4, so it's a composite number. So, only 1. So we do 1 over 4 to get the probability of event A, which is 0.25. So simply we write 0.25. The probability of B. So it says let B be the event that the sum of the scores of the 2 spinners, we need to consider both of them, is less than 8. So we can consider more than 8, and then we can find the complement to get it easier, because there are a lot of numbers in which if we add them we get less than 8. So we can get more than 8, and then we can do 1 minus the answer. So we do 5, 6, 7, 8, and then we do 6, 7, 8, then we can fill in these. So we have 1, 2, 3, 1, 2, 3, 4, 5. Okay, so we have 4 and 4 as well, which amounts to 8. So we have 6 which are greater than 8. No, like we have 6 values which are greater than 8. So we do the total number of arrangements, which is 6 times 4, which is 24, minus 6. 24 minus 6, which is 18. 18 is the total number of sums which are less than 8. So we do 18 divided by the total number of arrangements, which is 24, We do 18 divided by 24, we get 0.75. Okay, so A intersection B. What does A intersection B mean? So it means that spinner A has to be 4, and at the same time the sum of the two spinners has to be less than 8. So we only consider this column when finding the intersection. So we have 1, 2, 3, 4. We only have 4 cases where if we use 4 from the first spinner and we add it to the values of the second spinner, we get a number less than 8. So we do 4 divided by the total number of arrangements, which is 24. So we do 4 divided by 24, we get no wait, it's not 4, it's 3 here. So it's 3. So we do 3 divided by 24, we get 0.125. 0.125. Okay. Choose the option that best completes the following sentence. Based on the results obtained in part A, it can be concluded that events A and B are C. We found the intersection, and for the two events to be independent, the sum of A, the probability of A, and the probability of B must be equal to the intersection of both of them. So if we do 0.25 times 0.75, we put a box in between, 0.125. So we do on the calculator 0.25 times 0.75, we get 0.1875, which is not equal to 0.125. So it means that they are not independent or dependent. So not independent. So based on the results obtained in part A and part B, what is the value of union A and B in decimal form? So we need to use the union formula. What is the union formula? So probability of A union B is equal to the probability of A plus the probability of B minus the intersection of A and B. So we do 0.25 plus 0.75 minus 0.125. On the calculator, we do 0.25 plus 0.75 minus 0.125, in which we get 0.875. So let's fill in the answers firstly, then we can go to the next part. So part A, probability of A is 0.25, probability of B is 0.75, the probability of the intersection is 0.125. We found that they are not independent, and 0.875 is the union. So let C be the event that the sum of the scores is 5. Let D be the event that the sum of the scores is 9. Okay. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So let's see how many sums we have that are equal to 5. So we do 4 plus 1, which is 5. 3 plus 2, 5. 3 plus 2, 5. 4 plus 1, 5. So we have 4 outcomes favoring C and D, which is the sum of the scores is 9. So we do 5 plus 4 is 9, and 6 plus 3 is 9, and only 2 favoring D. They already gave us that the probability of C is greater than the probability of D. They just want us to find the number of outcomes of C and D. So we just write 4 and 2. Question 4. A flashlight is randomly selected from a box containing 20 flashlights, of which 4 are known to be defective. After being tested, the flashlight is returned to the box. If they tell you, like, they use a flashlight and then they put it back in the box, it means that this whole scenario is independent. Like the first flashlight taken away does not affect the probability of the second flashlight the second time the second flashlight gets taken away, because the first one is returned back in the box. So a second flashlight is then randomly selected from the box and tested. So what is the probability that the first flashlight is defective and the second flashlight is not defective? So there's 4 defective and the total is 20. So we do 4 over 20. This is simply the probability of the defective, of filling out a defective flashlight. So there's 16 not defective flashlights. So the probability of taking out a normal flashlight is 16 over 20. So what is the probability that the first flashlight is defective and the second flashlight is not defective? The first one does not affect the second one, so we just write it as it is. Then we multiply the probabilities. So we do 4 over 20. Wait, 4 over 20 times 16 over 20, in which we get 4 over 25. They want it as a decimal, as a fraction, I mean. What is the probability that the 2 flashlights are defective? Same scenario. So we do 4 over 20 times 4 over 20. The first one does not affect the second one, so we use the same probability for both. So we do 4 over 20 times 4 over 20, in which we get 1 over 25. What is the probability that at most one of the 2 flashlights is defective? So at most one of the 2 flashlights is defective is the complement or the opposite of none of them of both of them being defective. See, so we do 25 minus 1, which is 24. So it's 24 over 25. Yeah, so they are complements. So this is 2 defective and this is 1 or 2. I mean 0 or 1, so which is the opposite of 2. So like anything that is not 2. So forget about this, I was just testing out something. So it's simply the complement. So for the first one, it's... what was the answer? 4 over 25, I think. The second one was 1 over 25. And the third one was 24 over 25. Question 5. What is the probability that a random arrangement of the 7 letters of the word terrace has the 2 E's together? So terrace, it has 2 R's and 2 E's. Okay. So first of all, we need to find the total number of arrangements. So we do 7 factorial divided by 2 factorial times 2 factorial. So we put it on the calculator. So we do 7 factorial divided by 2 factorial times 2 factorial, in which we get 1260. So now they told us that the 2 E's are together. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 6 factorial. And the 2 R's are repeated, and we used up the 2 T's, so we don't divide by the 2 E's, so we don't divide by 2 factorial. So we do 6 factorial divided by 2 factorial, which is 360. And to get the probability, we need to divide 360 by the total number of arrangements, which is 1260. in which we get 2 over 7. So the first one is 2 over 7. So the probability, so the total is 1260. So probability that a random arrangement of the 7 letters of the word terrace has 2 E's together and 2 R's together. If it says and, it means that they want the intersection. So we have 2 E's and 2 R's together. So we have 1, 2, 3, 4, 5, 6, 7. So it's 1, 2, 3, 4, 5, 5 factorial. We don't divide by anything because there's nothing repeating, because we used up the 2 T's and the 2 R's. So we divide 5 factorial by the total to get the intersection of both of them, the probability of the intersection, which is 2 over 21. So part B is 2 over 21, and they gave us the numerator and they want k, so we simply write 21. What is the probability that a random arrangement of the 7 letters of the word terrace has the 2 E's together or the 2 R's together? If it says or, they want union. And we must apply the union formula, which is probability of E union R is equal to the probability of E plus the probability of R minus the intersection, the probability of E intersection R. So the probability of E and the probability of R are the same, which is 2 over 7, which we found in part A. So we do 2 over 7 plus 2 over 7 minus the intersection, which is 2 over 21, equal to. So we put it on the calculator. We do 2 over 7 plus 2 over 7 minus 2 over 21, in which we get 10 over 21. If you don't know how to simplify a fraction, you can just put the fraction on the calculator and it simplifies it automatically. It's just a random fact that I wanted to tell you. Let M be the event that a random arrangement has the 2 E's together. So M, 2 E's together. 2 E's. And N, which has the 2 R's together. So to check if these two events are independent or dependent, the probability of M times the probability of N must be equal to the intersection. If they're not equal, that means that they're not independent. So we have the probability of M to be 2 over 7, which we found in part A, and the second one is the same as the first one, and we put a box in between, and we put the intersection that we found in part C, 10 over 21. So 2 over 7 times 2 over 7, we get 4 over 49, which is not equal to 10 over 21, so they're not independent or dependent, because this intersection is not equal to the product of these two probabilities. So they're not independent because this is not equal to that. So question 6. Every Saturday, Peta attends a choir rehearsal taking place at a city concert hall. She arrives early, on time, or late with probabilities. So early, the probability of E is 0.2. The probability of on time is 0.68. And the probability of late is X. We need to find it. What is the probability of late, which is P in this case? So all of these three added must be equal to 100%, or 1 in probability. So we do 0.2 plus 0.68 plus x or plus p is equal to 1. So we find it on the calculator. So we do 0.2 plus 0.68, 1 minus the answer, we get p is equal to 0.12. Okay. What is the probability that Peter arrives on time to the concert hall on 3 randomly selected Saturdays? There are 3 randomly selected Saturdays. Each Saturday does not affect the next Saturday, so they're independent events. So they want Peter to arrive on time, so we need to use on time, which is 0.68 times 0.68 times 0.68, which is equal to 0.68 cubed. So we put it on the calculator, we get 0.314 to 3 significant figures. So we have 0.12 and 0.314. Audra randomly selects 3 cards, one after the other without replacement. If they say without replacement, it means that the events are dependent. That means one probability affects the next probability. From an envelope that contains 5 blue and 7 yellow cards. So the total number of cards is 5 plus 7, which is 12. The probability that all 3 cards are blue. So Audra selects a card from the 12. The first probability is 5 over 12. And then after she took the first blue card, we're gonna have 4 blue cards left and 11 cards left in total. And then after we take another card, we're gonna have 3 blue cards and 10 left. Oh wait, we multiply them. We multiply all of the probabilities. So we do 5 over 12 times 4 over 11 times 3 over 10, in which we get 1 over 22. So k is 22. What is the probability that exactly one of the cards is blue? So she is selecting 3 cards. One of them is blue. So we take the first one. Okay? Times. We have 11 cards left. If one is blue, that means the other 2 cards have to be yellow. So we take, so it's 7 over 11 because we took 1 blue card, so we have 11 cards left in total, times, after we take the yellow card, we have 6 yellow cards left and 10 total cards. So we multiply all the 3 probabilities. So times 7 over 11 times 6 over 10. We get 7 over 44. And there's 3 different scenarios in which we can arrange the cards. It can be blue, yellow, yellow. Or it can be yellow, yellow, blue. Or it can be yellow, blue, yellow. There's 3 different ways where we can arrange the 3 cards that we chose. So we just simply multiply the probability of one of them times 3, in which we will get 21 over 44. So the first one is 22. The second one is 21 over 44. Oh, a standardized exam is offered in three formats. The probability that a student chooses format A is 0.4. The probability that a student chooses format B is 0.45. And the probability that a student chooses format C is 0.15. Okay, the probability that a student chooses format A and passes the exam. So the probability A and passes the exam, so intersection pass, is equal to 0.27. And the probability that a student chooses format B and passes is equal to 0.15. And the probability that a student chooses format C and passes is equal to 0.18. What is the probability that a randomly selected student passes the exam? So we simply add all of these probabilities. There's only 3 cases in which the student can pass. It can either be an A, B, or C. So if we sum up the probabilities in which he participates in A and passes, and B and passes, and C and passes, we get the probability that he passes the exams in general. So it's a bit confusing, but if we understand it, inshallah, it's very, very easy. So we get 0.6 after adding them all. No, wait, format B is 0.36. Okay, 0.27 plus 0.36 plus 0.18, we get 0.81. A student is randomly selected. Let E be the event that the student passes the exam, which is 0.81, and C be the event that the student chooses format C. So PC equals 0.15. So they want us to see if the probability of C intersection P is a dependent or independent event. So the probability of C times the probability of E space the intersection given, which is 0.18. If they're equal, it means that it's independent, and if it's not equal, it means that they're not independent or dependent. It's the same. So 0.81 times 0.15, which is 0.1215, which is not equal to 0.18. So they are not independent because this intersection is not equal to the product of these two probabilities. So 0.81, they're not independent because they're okay. Question 9. Let M be the event that a random arrangement of the 8 letters of the word obsolete has has the 2 O's together, and let M be the event that it has the 2 E's together. So M is 2 O's together, and N is the 2 E's together. How many repeated letters do we have? We have 2 O's and we have 2 E's, simply. And to get the total number of arrangements, we do 8 factorial divided by 2 factorial times 2 factorial. So we put it on the calculator. We do 8 factorial divided by 2 factorial times 2 factorial, in which we get 10080. The number of all possible arrangements of the letters in absolute is the number that we just found, which is 10080. The number of elements in X is equal to the number of elements in Y. I don't know why they changed it to X and Y, but it refers to M and N in this question. So the elements of X is equal to the elements of Y, the number of elements in Y. So we have Let's take, for example, two O's together. So we have 1, 2. We consider this as 1, 3, 4, 5, 6, 7, 8. So we have 1, 2, 3, 4, 5, 6, 7. 7 factorial divided by the number of repeated, which is 2 factorial. In each case, it's the same. So we do 7 factorial divided by 2 factorial, in which we will get 2520. The number of elements that are common to x and y. So it means that they're common in both of them. So if it's they want the intersection of both, in which the two O's are together and the two E's are together. So we do OO as one block, EE as a second block, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And there's nothing repeated, so we simply do 6 factorial on the calculator. We get 720. So it says the probability of x is equal to the probability of y, which is equal to 2520, which we found in part B, over the total arrangements, which is 10080. 10080, which is 0.25, and the intersection is equal to the intersection that we found divided by the total number of arrangements, which is also, they wanted to do the 2 decimal places. So we do 720 divided by 10080, in which you will get 0.07. And in the part C, they want us to see if they're independent or dependent. So same story. So we do 0.25 times 0.25 box 0.07. 0.25 times 0.25 is equal to 0.0625, which is not equal to 0.07. So it means that they're not independent or they are dependent. So let's fill in the answers. So it's 10080, 2520, 720. This one is 0.25, and this one is 0.07, and they're not independent. Okay, a fair 8-sectored spinner with sectors numbered 1 through 8 is spun twice in a row. Let A be the event that the number the spinner landed on the first time is a factor of 9. What are the factors of 9? We have 1, 3, and 9. But we cannot choose 9 because the spinner only has 8 sectors. It doesn't have any more than that. So we can only choose 1 and 3. So it's 2 over 8. Let B be the event that the number the spinner landed on the second time is at least 6. So it has to be 6 or more. So it has to be 6, 7, or 8. So it's 3 over 8. So because they said it's a fair 8-sectored spinner, it means that it's not biased. The first spin doesn't affect the second one, so it means that the 2 events are independent. And to find the intersection of 2 independent events, we can just add the probability of each event together and find the product. So we do, on the calculator, we do 2 over 8 times 3 over 8, in which we will get 3 over 32. Okay, Bismillah, inshallah, it's correct. Okay, alhamdulillah, it's correct.